Good morning, friends. We are back with a new video on the algorithm decision trees. This is one of the main algorithm which is used in the various machine learning techniques. In the initial video, we learned about linear regression and logistic regression. Hope you people have found those videos good and helpful for your career or interview questions. If you have not watched those videos, please watch those videos, and before those I would like to say please watch the evaluation video and the gradient descent video, which is very important to understand before starting any type of algorithm. Today let's start with a new algorithm, that is decision trees. We'll also try to understand how it is implemented in Python with a random data set. If we see the definition of decision tree, we can say it's a type of supervised learning algorithm. In the initial videos, I have discussed about the difference between the supervised machine learning algorithms and the unsupervised one. If I say anything is supervised, that means you are having a target variable in the datasets itself. That is, you are being supervised, you are being taught, you are being learned. And the unsupervised, we do not have any type of output variable in our data set. For example, if you want to see a pattern in a particular market, how the customers are buying something, you can just check the pattern, find the pattern, but you cannot have an output in your data set. Based on that particular pattern, you can make some decisions, but that is unsupervised type of learning. Decision tree is a supervised type of learning where you are having the target variable in the dataset itself. Decision tree is used in the classification as well as the regression problem statements. In these smaller classes, for example, in the college or in the school, we have learned about small decision trees. For example, whether tomorrow you'll go to school or not, how a mother decided it. You can see whether the child is ill or the person is sick. Obviously, the person will not move to the school or the college next day. This means there is certain factors based on which a decision is taken. So, if I say a normal flow diagram, I can have a root node as is sick. If it is yes, the person will say that he will not go to school, that is 0 variable, and if the person is not sick, he will go to school, that is 1 variable. This is one of the very simple example of the decision tree in the day-to-day life. If you see in terms of coding, we know in many cases we have to implement many if-else loop. Again, this is a type of decision tree because you are deciding a particular output based on certain input which is written in the if statement. Now let's see, I have given a data set here which is having the weather conditions of a particular place, and based on which we will be deciding whether a person will play golf or not. See, there are certain variables which are considered as outlook, temperature, humidity and windy, and we are having certain predictors. Now, we know in the data set we contain two things. One is the independent variable and other one is the dependent variable, or we can say there are certain features based on which we are finding the output. Now see, the outlook contains various factors like rainy, overcast and sunny. The temperature may be hot, mild or cool, and the humidity may be high or normal, and windy, it may be true or false, that is whether that particular day is windy or not. If we see the first row, we can see if my outlook is rainy, temperature is hot, humidity is high and the windy is false, we are not going to play golf. That is, our target variable is considered to be no. Now, if I convert this particular whole data set into a graph, I can say if the root node is outlook. In the further discussion, we will find out how to find the root node. For now, you can just understand we have taken it randomly. We have taken outlook as the root node, and then based on the decision, if my outlook can have only 3 values, that is sunny, overcast and rainy. So, if my outlook is sunny and my windy is my false, false and true value. Windy will have the false and true value. That is, if my outlook is sunny, windy is true, then we will not play golf. If my outlook is sunny, windy is false, we will play golf. That is, my yes-no decision is based on this particular route diagram. That is, if my outlook is overcast, irrespective of any other feature, that is temperature, humidity and windy, always my target variable is considered to be yes. So this type of trees are called decision trees, where we are finding the output may be yes or no based on certain features. This features will be coming from the old data set. That is the historical data set or the pattern data set, which will actually be fed to a computer to learn different things and then become a supercomputer who will give us the output itself without any human intervention. I think you people remember the definition of machine learning, where we say we are making a computer learn so as to give an output without any human intervention. But initially you have to make the computer intelligent by giving you lots and lots and lots of data. There are certain terms which is used and associated with the decision trees. These are root node. It represents the entire population or sample, and this is further divided into two or more homogeneous sets. Then is the splitting. It's a process of dividing a node into two or more subnodes. Then is the decision node. That is, when a subnode splits into further subnodes, then it's called a decision node. Then is the leaf or the terminal node. Nodes do not split. Nodes as called the leaf or the terminal node. That is the last node. It is not splitting anymore. Then is the pruning. When we remove the subnodes of a decision tree, this process is called pruning. You can say opposite process of splitting. See, we can have n number of features and n number of levels in a decision tree. But it may be that certain features are not affecting it. So with the increase in the number of features, we increase the level of the decision tree, and this makes it highly complex. You can also see that as each and every decision comes out in the decision tree will always suffer from overfitting problem. I think you people know about the overfitting problem, as I've already discussed in the initial videos. If not, please pause the video here, move to the overfitting video, have an idea about overfitting, how we are solving overfitting and why and how the overfitting is occurring. Then come back to the decision tree, then have a thought why decision tree is suffering from overfitting and how can we solve it. Next is the branch or the subtree. This is the subsection of the entire tree is called a branch or a subtree. Then is the parent and the child node. A node which is divided into subnode is called a parent node of the subnodes, whereas the subnodes are the child of the parent node. If we go in the previous slide, I can say the root node is my outlook, and the last nodes where I have written yes, no, no, yes, this will be my leaf node, that is my decisions. Now let's see the algorithm of the decision tree. Today we'll discuss the algorithm which is called the ID3, which actually uses the entropy and the information gain to construct a decision tree. Let's understand the term entropy. A decision tree is built top down from a root node and involves the partitioning of the data into subsets that contain the instances with similar values which are homogeneous in nature. ID3 algorithm uses the entropy to calculate the homogeneity of the sample. See, actually entropy is like how messy is your data, how random is your data. Any person who is having a background of chemistry or have learned the chapter of thermodynamics in physics or chemistry, you must know what is entropy. When we calculate the entropy of a particular gas, that is a particular molecule, how messy it is, how random it is, that is called entropy. So messiness of the data, that is how random is my data, this is measured in terms of entropy. If the sample is completely homogeneous, that the entropy is 0, and the sample is equally divided, it has an entropy of 1. Now let's understand what is information gain. The information gain is based on the decrease in entropy after the data set is split in an attribute. That is, For example, in the initial example, I have discussed as root node is Outlook. Now, when we are fixing the root node as Outlook, the whole decision tree, that is the next level of decision tree will be made without seeing the condition of Outlook. Therefore, we have to see, once we have decided the Outlook based on the entropy, how much there has been decrease in the entropy of the other particular decision trees made without looking at the feature Outlook. This is called information gain. Constructing a decision tree is all about finding the attribute that returns the highest information gain, that is the most homogeneous branch. So there are certain mathematical formula. I am not going to deep dive into these formulas for the derivation. If you want, you can refer to other YouTube videos or other books which will actually gives the derivation. But for the machine learning algorithm to understand, we are okay that we are using an algorithm which is using the entropy as a factor, and you must know what is entropy conceptually. This comes the mathematics of the entropy. Firstly, we are calculating the entropy of 5 and 9. See, from where the figures of 5 and 9 are coming, I have this particular data set. We have the total number of data set, that is the how many lines of code in here. Then we are discussing what is the entropy of playing golf, that is what is the total number of data sets, that was 9, and how many times the person has played golf, that is 5. So we are finding the entropy of 5 and 9. It is calculated as 0.036 log to the base 2 of 0.36 minus 0.64 log to the base 2 of 0.64, which is 0.94. This is seen in terms of probability. I can say that if I see the entropy of T and X, that is the sigma, that is the summation of probability of C and E of C. See, you can see the graph here where it is shown that if outlook is sunny, overcast is rainy, then how many times we are playing golf? 3 times yes when sunny, 4 times yes when overcast, and 2 times yes when rainy. And totally opposite will be the no. 2 times when sunny, 0 when overcast, and 3 when rainy. That is, the total number will be 14 and total outlook variable will be 5, 4 and 5. So we are calculating as 5 divided by 14, that is E of 3, 2 plus P of overcast into E of 4, 0 plus P of rainy into E of 2, 3. This value comes out to be 0.693. See, every time we have to calculate the entropy and the information gain, and the thing which will have the highest information gain will be the root node. This way we are calculating the entropy on each and every value, that is outlook with the 3 values, temperature with the 3 values, humidity with the 2 values, windy with the 2 values. Then we are trying, and every time we have found the gain, then we are trying to find the gain, that is the entropy of T minus entropy of Tx. We are finding the gain and I have directly written the formulas here. Based on those formulas, I have calculated the value. You can calculate the value with the help of pen and paper. Take the formula of the entropy, or you can have certain calculators on the internet which directly gives you the entropy when you put the values on it. So we are finding the gain of each and every value with the target variable as playing golf. Then we are choosing the attribute which is having the largest information gain as the decision node. That is, in this case, if we see, we are finding that outlook is having the maximum gain, that is 0.247. Now we are considering the outlook as the node, parent node. So now what we will do, we will have a decision tree which the first node will be our outlook. Outlook can have 3 values, that is rainy, overcast and sunny. Now we will have 3 different tables. Every time outlook is sunny, we have all the values, then for overcast and then for rainy. Now we will remove this feature outlook and we will remain with the table which contains temperature, humidity, windy and play golf, and this will have 3 different tables. Now based on these tables, the whole process will be repeated again and again to find the next parent node. See, if we check this, in case of overcast, whatever the value of temperature, humidity and windy is, always the value of play golf is yes. So we do not need to calculate anything, and we can say if my outlook is equal to overcast, always the play golf value will be yes, irrespective of any other condition in my data set. So see, so that is why in this particular decision tree for overcast I have written play is equal to yes. Now we have two other things, that is for sunny and rainy. Again we will make the graphs and find what would be our parent node. Now after sunny we find that our parent node, if it is windy, we see if windy is false, the play is always yes, and if windy is true, play is always no. Similarly we can do for the rainy and we can get the next graph. So the full final graph that is being created is something of this way. We can also write this in terms of if and else terms, and these are called decision rules. That is, rule 1 is if outlook is sunny and windy is false, then play is equal to yes. If outlook is sunny and windy is true, then play equal to no. Then if outlook is overcast, then play equal to yes. If outlook is rainy and humidity is high, then play equal to no. And if outlook is rain and humidity is normal, then play is equal to yes. This is all about the decision tree that has been drawn here. You can pause the video, look at the decision tree and try to interpret various things. Let's say if for tomorrow, if you are given a question whether you will play golf or not if humidity is high and outlook is overcast, you can directly say based on the past values, yes, a person will play. Because whenever we are having the condition as outlook is overcast, whatever the other features you are giving, always we are having that golf play is equal to yes. This is actually what the decision tree decides about your answer, about your target variable, that is about your output. But the most important thing which decision trees suffer from is the overfitting methods. This is why we have to decide how much level our decision tree should go and where should we cut the leaves. This is what is called pruning. Pruning is one of the techniques how we are solving the overfitting issue with the decision tree. One more algorithm which is based on exactly the decision tree is the random forest. See, decision tree actually makes single decision tree with many number of levels, many number of nodes. But random forest gives the multiple decision tree where you have to decide what is the number of decision tree you are making. For example, you are making 5 decision tree, it is giving 5 various decisions and then having like you can average them up all or give the weightage average of it and then find what is your actual decision. Random forest is also an algorithm which helps to find which feature is important. That is recursive feature engineering. It actually tells what is the weightage of each and every feature that you are using in your particular data set. I have discussed about the random forest tree. The higher the number of trees in the forest, the more the accuracy. This is one of the techniques or one of the algorithm which helps decision tree to overcome the problem of overfitting. Random forest tree is again one type of supervised learning algorithm which is having some target variables and which creates multiple decision trees. Give a pause to the video. You can recap that video like what was decision tree, how we made the decision tree, how were the features decided, what is entropy, how you decided the information gain. Based on that particular gain, you found out the node. After finding the node, you then again tried to make a subtree or a subtable, sub-data set, and then based on that sub-data set, again the full method was iterated, that is, it was recursive thing. Each and every time you have to calculate the information gain and the entropy, and this way you have to keep on making the decision tree. Now, when we implement this in Python, it becomes so easy. This is because you don't have to decide anything. You just have to say like whether you are using the entropy or you are using the Gini index. Just based on these, it will find out a particular graph and a decision tree. But the output which Python gives in a particular format which is a little bit difficult to read. So there are certain other type of libraries like GraphViz library which actually gives the decision tree in terms of a graph which is easily visuable. That is, you can easily see it, and just by looking at it you can see about what type of decision the computer has made based on your data. Now let's check how we are implementing it in Python. As every time we do, we are importing NumPy and Pandas as NP and PD, which is used for linear algebra and the data processing. We are having a data set, that is mushroom.csv. Please see the data set from the GitHub. I have uploaded the full code and my data set. Now, once we are converting this particular mushroom.csv into the data frame that using the pd.unread_csv. Now we are finding if there is any type of null values. This is a part of data cleaning or data engineering, where we do the data if it is null in any type of axis is equal to 1, that is in a particular row. Then we are dividing, before dividing we are importing the train test split. We have done this each and every time we have implemented any type of model, may it be linear regression, may it be k-means, may it be logistic regression. Now what we do, we know our y should have only the output variable, that is df class. So we are dropping it from the x variable and just assigning it to the y variable. So my x contain all the inputs and y contain only the output. Now we are converting, that is we are using the getDummies function. We are getting the categorical variables into an indicator variable. We are doing it for both x and y, and then we are trying to bring the x.info and the y.info. Now there are certain evaluation terms which I have already discussed in the older video, that is the evaluation and how to evaluate things using Python using various libraries. One of the evaluation is the cross-val score, that is a cross-valuation score. We are importing the tree because decision tree is a part of the tree. Then we are also importing the grid search CV, which actually tells what are the best parameters we should use to see, like for example, if you want to see how many pruning levels should be there, how many leaf nodes should be there, what is the depth of the decision tree that you are deciding, which would be the best factor to which actually gives the highest accuracy. These all are directly given by the grid search CV. Now we are dividing our test data into the trace data and the train data by using the module train_test_split. We are giving the parameters in x and y. We are getting the output as 4 variables, that is x train, x test, y train and y test. Now the parameters that we are deciding is criteria as Gini and entropy. We want to make the decision tree as both using the Gini index and the entropy. Next is the minimum sample split. We are giving us 2, 3, 4, 5. Then is the maximum depth 9, 10, 11, 12. Class weight, that is balanced, and pre-sort, that is false. Okay. Now we are trying to make a decision tree classifier object, that is we are making a model TR which is equal to tree.decision tree classifier. Then we are making a gsearch is equal to, we are making an object of grid search CV which is having the parameters as the parameters that we have already decided and the model that we have made from the decision tree classifier. Then we are using to fit it, and then this model will print us all the best estimators that we have given the range. Now we are printing the model and we are printing the score. I just discussed like this type of graph, decision tree graphs, where if you normally print it, you will have the output in terms of certain things which is written in text. It is quite difficult to read. But if you want to visualize it as a flowchart diagram or a normal decision tree, we are importing the GraphViz. Now whenever we are importing it and whenever you are making a decision tree, it makes a dot file. We are converting it into a graph. I'll just show how the output looks like. This is the normal decision tree. Whenever that is a printing of the dot file. Decision tree which is directly made, which you cannot see in the graphical manner, is in this form, where you are having some arrows which indicates what is the parent node, what is the leaf node. if we have little bit of time, you can go through the whole output, then you can easily understand, but it takes time and it is not so that easy to understand for a layman. But every time you keep on looking at it, you will understand it. So why, when you become an expert, it's very easy for you to understand this too. But if we have the graph viz and just have the directly visualize it in a graphical form, that is something of this form, it becomes easy for you. Just by looking at it, you can directly say, okay, if my value is A and then it comes to B, then we are getting an output of ABC, and so on. So the visualization parts become easy when you're using the graph viz. But the main thing is that while making a decision tree, you have what type of indexes are you using, what type of parameters are you using, when are you pruning it, what is the level of decision tree, how many splitting are you allowing. This is all the most important to decide how your algorithm will work and how your algorithm will have the maximum efficiency. I would like you people take a pen and paper, firstly go through the example that we have discussed, that is the Outlook one. Once it is done, exactly have the copy of the data in your Excel sheet. With such a small set of data, use the same data and apply it to the Python code. Just instead of mushroom.csv, which I have used and also uploaded in the Git, you can use that particular file. For example, you can name it playgolf.csv. Just replace that playgolf.csv and then see whether manual decision tree that you have made by pen and paper, how it is similar or different from the Python code that you are being implementing. It is my gut feeling always you'll get the same value. This is because again the computer works by the algorithm that we have defined to it. The algorithms or the libraries that are written that has the same code which I am explaining conceptually. But obviously when one code is written, we always use it as a function or we use it as a library, because every time you keep on developing that code for the same piece of logic, it is of no use. So making it redundant, there are certain people who have made or converted this into library, and hence you are using the library directly, and just by changing the certain parameters you can make your logic, you can make your algorithm more accurate and more efficient. So before going into the decision tree, just have an idea about what is linear regression and what is logistic regression, then come to the decision tree. Hope this video will help you. I have uploaded the full code in the GitHub. Also the dataset has been uploaded. Please go give a look to it, download it, run it, or write your own code and see how decision tree works and how you are implementing it in Python. Have a great day. Have a nice time. Thank you. Bye bye.